In this video, we're going to look at the relationships between parts of circles. More specifically, we're going to look at properties of tangents. A tangent line to a circle is a line that is just going to touch the edge of the circle. It's going to cross the circle in exactly one point. The point of tangency is the point where the circle and the tangent intersect. So in the picture here, point B is our point of tangency. Something special about the way the radius and the tangent line connect is that the radius and a tangent will always cross at a 90-degree angle. So radius, tangent, think 90-degree angle. In this first sample problem, we are given that PQ is tangent to circle S at point P. You'll notice that where the radius and the tangent meet is marked as a 90-degree angle. It's our job to figure out the radius of circle R. Well, the radius of a circle is always going to be the same no matter where it's drawn. So PS is X, and I know that this other chunk here is also X. What I see here now is a right triangle, and to figure out the missing side in a right triangle, I'm going to think Pythagorean theorem. Before I get started though, I'm going to take a look at my hypotenuse. The entire thing is, I have a 4 centimeter chunk and a X chunk, so the whole thing is 4 plus X centimeters long. So now I'm going to plug into a squared plus b squared equals c squared. So I'm going to plug in x squared plus 6 squared is equal to 4 plus x squared. I'll clean up the left-hand side, so I have x squared plus 36 equals, and now in order to square that x plus 2 term, square binomial, I need to write it out twice. And that's my clue that I need to FOIL. Remember, FOIL says first, outer, inner, last. So if I multiply my first terms together, 4 times 4 I have 16. My outside terms, I have 4x. My inside terms, I also have 4x. And my last terms, x times x, gives me x squared. So now I'll clean up the right-hand side. 4x plus 4x gives me 8x. I notice both sides of my equation have an x squared on them, so I'm going to subtract x squares on both sides. So these reduce, and I'm left with 36 equals 16 plus 8x. If I want to get my x all by itself, my next step is going to be subtract 16 on both sides. So I have 20 equals 8x. And last but not least, I'm going to divide both sides by 8, which leaves me with x is 2.5. So my radius is 2.5 centimeters long. In this next problem, we're asked to find the distance between the centers of the pulleys. You'll notice that we have a radius connected to a tangent, so I'm going to mark those in as 90-degree angles. And it's our job to figure out the distance between these two. Well, I notice that this here is 6 inches, and I'm going to mark down 6 inches over here. If I do that, I'm going to connect and make a parallel line. Let's make that a little straighter. Alright, when I do that, the top chunk is 6, so the bottom chunk must be 4. Well, this line and this line must be parallel, which is also 20 inches long. Since I have parallel lines, I can think corresponding angles, alternate interior angles, all that good stuff. So there's a 90-degree angle hanging out down here. So now what I have is a right triangle. So now I can figure out a squared plus b squared equals c squared. So I'm looking for my hypotenuse. It's the longest side across from 90. So if I think a squared plus b squared equals c squared, and I can plug in 20 squared plus 4 squared equals c squared. So 400 plus 16 equals c squared, or 416 equals c squared. Now to get c all by itself, I need to get rid of that squared, so I'm going to square root both sides, and I'm left with approximately 20.4 inches for the distance between those two pulleys. In this next example, we want to figure out if AC is tangent to circle B, and we're going to explain. Well, the converse of the tangent property says that if our three side lengths fit into our a squared plus b squared equals c squared, so if we can verify that angle A is a right angle, then AC must be tangent. So let's see, is it a true statement? A squared plus b squared equals c squared. My longest side is C, so 25. So I have 7 squared plus 24 squared equals 25 squared. I want to see if that's true. So 49 plus 576. I want to see if that's equal to 625. I end up with 625 is equal to 625. So yes, AC is tangent to circle B because the radius and AC form a 90-degree angle. We have one more property to talk about, and that says two segments that are tangent to a circle from a point outside the circle are congruent. So if AB and CB are tangent to circle O at A and C respectively, then AB is congruent to CB. So tangents that meet at a point outside the circle are congruent. Now let's apply that last property. I notice that my circle is surrounded by tangents, and I see a bunch of tangents meeting at points outside the circle, points A, B, and C. I know points that meet, or tangents that meet at a point outside the circle, create congruent segments. So this chunk here has to be congruent to this chunk here. Here and here are congruent, and this piece are congruent. So if I look at this first chunk, that's 4 centimeters. This next chunk must also be 7 centimeters, and the last chunk has to be 2 centimeters. If I want to find my perimeter, I'm going to add them all up. So I have 4 plus 4 plus 7 plus 7 plus 2 plus 2, and I end up with 26 centimeters as the perimeter of triangle ABC.